Today we will solve one question from the series of jump game questions. Let's look at the problem statement. You are given an integer array nums and you are initially positioned at the index 0, and each element in the array represents the maximum jump that can be taken from that position. We have to return true if we can reach the last index, else return false. Now, let's understand the question with some sample test cases. Let's look at the first test case given. So here the nums array given is 2, 3, 1, 1, 4. The value at index 0 is 2, which means from index 0 we can take maximum 2 jumps. And that means we can go to index 1, or at max we can go to index 2 from index 0. Similarly, the value at index 1 is 3. That means from index 1 we can go to either index 2 or index 3, or at max we can go to index 4. Likewise, we have to check if we can reach the last index, in this case index 4, starting from the index 0, as it is mentioned that the initial position is index 0. See, as we can reach the last index from the starting index, which is index 0 in this example, we will return true. See, we can take the jump one step from the index 0 to index 1. Then we can take 3 jump steps from index 1 to index 4, which is the last index. Hence, we will return true. Now coming to the second test case, we can always reach till index 3 from index 0, index 1 and index 2. But from index 3, we can't take any jump step further. Hence, we can't reach last index, which is index 4. Hence, we will return false. Now let's look at the naive or the brute force solution for this question. For each index I, we can explore all possible jump steps, and we will check if we can reach the last index. So here we will be using the recursion to solve this question. Now let's look at the recursion tree for the solution. Okay, now let's draw the recursion tree. So the array given is 2, 3, 1, 1, 4. And if we write the indexes 0, 1, 2, 3, 4. Right? Now let's draw the recursion tree. Now the node structure for the recursion tree will be index, value at index, and let's say the remaining array or indices. So if we draw, or if we start from the 0th index, so 0, value is 2, and the remaining is 1, 1, 2, 3, and 4. So from 0th index is having value 2, so we will be having 2 branch. What the indices we can go to? Index 1 with value of 3, and the remaining indices will be 2, 3, and 4, or we can go to index 0 with index 2 with value 1, and the remaining indices will be 3 and 4. Now here index 1 we can take 3 steps, so we will be having 3 branch. One is we can go to index 2 with value 1, and the remaining indices will be 3, 4. Or we can go to index 3 with the value 1 with remaining indices 4. Or we can go to index 4 with value 4 and remaining indices is empty. Similarly, here index 2 is having value 1, so there will be one option. So we can go to index 3 with value 1 and the remaining indices to explore will be 4. Here again, a single branch. So index 3 with value 4 and the remaining will be 4. Here also index 3 value is 1. So one branch which is 4 comma 4 and we have explored all the indices. It is empty array, so we are no need to explore further. Similarly here also this one. Similarly here also this one. As you can see, starting from the start index 0, we are able to get a position where we have reached to the last index and we are having a empty indices to explore. That means we can return true, right? Here you can see we have overlapping, right? Here we have overlapping, and the overlapping cases are like this one, similar. Then you see this one, this one, this one. These are the overlapping cases. And this recursion tree, this approach will take exponential time to complete this problem. So we have to look for some optimal or improved solution. Next, we will look at the better solution. Now, let's look at the better solution. So the given array is 2, 3, 1, 1, 4. Let's write the indices 1, 2, 3, 4, and 5. Okay. So for current index I, 0, we have a value of 2. So that means from index 0, 2 is our maximum reach. Okay. Now we will go to index 1. As our maximum reach is index 2, so anyway we are able to reach index 1. So now from index 1, the value is 3. That means the max reach will be current index plus the value which is 4. Whenever we are encountering last index which is n minus 1, we can say like we have reached the last index and we can return true. So what we are doing, we are for each I, we are calculating what is the maximum index that we can reach. Okay, and then we keep on exploring the next indices until unless that index is less than this maximum reach. If it is so, then we can check if maximum reaches n minus 1 or not. If it is, then we are able to reach the last index starting from the index 0, hence we will return true. Now let's quote the better solution. Here we are taking the nums array size, and then take the current index and check one more variable which is max reach, which is initialized to 0. Now for I0, I less than n minus 1 as and I has to be less than equals to max reach I plus plus. Okay, now the max reach will be maximum of max reach and I plus nums of I, which will be my next max reach. If maximum reach is greater than equals to n minus 1, we will return true. If not, then we will return false. And as I already mentioned, this part, why we are doing this thing, because anytime if we are exploring one index I which we are not possible to reach from the previous indices, then we have to return false. So we are breaking down from the for loop and we will be returning false. Now we have to add the base case. So the base case will be if n is 1. That means we don't have to do anything. We will return true. We are already in the last index. Or if we are in, and 0 means it will be anyway, it will be returned false. Let's run this thing. It's got accepted. Let's submit this. And it's got accepted. Now looking to the time complexity. Time complexity will be order of n, as n is the number of elements in nums array, as we are exploring each element once. And talking about the space complexities, it is order of 1 because we are using constant space. Thanks for watching.